Okay, today's lesson is going to start on page 57. It's 2.2D. It says class activity, rate of change in a linear relationship. So today we're going to look at graphs, and we're going to try to figure out what's going on with them. Like, we're going to try to tell a story about them. We're going to try to match stories to the graph that is given. So if I look at number one says the graph below shows the distance a cat is from a bowl of milk over time. So which sentence is a good match for this graph? So we go back and we look here. We see our x-axis is time in seconds, and then this is distance in feet. So this shows the distance a cat is from his bowl of milk over time. So I see at 0, it's important, at 0 time, you look here, he's 0 distance from his bowl of milk. But as the time goes on, you'll notice that the distance starts to grow and grow and grow, till eventually he's at 4, which represents seconds, and then 12, which represents feet. So at 4 seconds, he's now 12 feet away from his bowl. So he started at his bowl, and then he moved away. So at 4 seconds, he's 12 feet away. So we need to go look at these statements. Let's see, the cat was 12 feet away from the milk, ran toward it. Nope. He was not 12 feet away. He started at it. The cat was 4 feet away. No, he started at it. The cat ran away from the milk at a rate of 3 feet per second. Possibly. The cat ran away from the milk at a rate of 4 feet per second. Possibly. So now we need to go and determine what does that mean. At 4 seconds was 12 feet. So if I take 12 and I divide it by 4, you're going to get 3, which means that he's moving 3 feet per second, which is going to identify letter C as the correct choice there. Okay, number 2. Write everything you can say about the cat and the distance he is from the milk during this time. So we can say the cat started at the milk bowl. So he started at the milk bowl. He then ran away from the bowl, and we can say this, at a rate, so that means speed, at a rate of 3 feet per second. When you do a slash like that, that means per, so 3 feet per second. There's second abbreviated. All right, now number 3 says, well, let's go ahead and use this information and create a graph, or create a table there to the right. So up here I need to put my labels, and I know this is my x, this is my y. So if I look at my x was the time in seconds. So I put time up here, and then we put seconds in parentheses. And the y we see was distance in feet. Okay, so I can put distance here, and then in feet. Okay, so I know that at 0, I'm going to start with 0. 0 time, he was 0 feet away, just based off that. And then if you look at the graph here, it doesn't list like 1, 2, 3, 4, but it does tell you at the very end 4 and 12. So because of that, I'm going to go down, I'm going to list that very last. So 4 and 12. And if I see what I have in here, I got 1, 2, 3, so I can put 1, 2, 3 there. Okay, if we know that he's moving 3 feet per second, so after 1 second, he's got to be at 3 feet, which means after 2, he's at 6, and after 3, he's at 9. Okay. Is this a proportional relationship? Now, to be proportional, here's what you got to have. It has to start at 0 and has to be a straight line. So when you graph it, it starts at 0 and it's a straight line. And if I look at this graph, it starts at 0, which means it doesn't start like somewhere up here on the y-axis. Okay, it starts down here. It starts here, and it's a straight line. So yes, so we can say yes, it's proportional. Okay, find the unit rate in the story. We already talked about that. The unit rate was comparing to 1 of something. So that was this right here. That's that 3 feet per 1 second. Okay, always compare to 1 of something. So I say it's 3 feet per, and we can even say 1 second there. 3 feet per second. All right, we're going to turn the page. Go to page 58. And page 58 says, sketch a graph for each of the 4 stories from number 1 on the previous page which you didn't choose. Label the graphs by letter to match the story. Find the rate of change for each story as well. Okay, so let's go back and look at letter A. So letter A, the cat was 12 feet away from the milk, and it ran towards it, reaching it after 4 seconds. Okay, so if I come over here, my graph is already labeled, my X, my Y axis there, and it says it was 12 feet away at 0 seconds. So 12 feet at 0 seconds. And then it runs toward it and reaches it after 4 seconds. So that means after 4 seconds, it's now 0 feet away. So 4 seconds, it's at 0 feet away. Okay, you can use a straight edge then, connect those points. And we should have a graph like that. So this is going to be letter A. Now the rate of change. Okay, the rate of change. See our graph is going down like that? And if it's going down, it's got to be a negative rate of change. And this negative rate of change is the opposite of the other one. So instead of traveling 12 and 4, like we did the positive, it's going negative 4, 12 divided by 4 is 3. I get my math facts right. So negative 3 feet per second. Your rate is negative 3 because it's coming closer to the bowl instead of going away from it. Okay, letter B is going to be this next graph over here. If I look at the next graph, I see letter B, the cat was 4 feet away from the milk and ran toward it after reaching it after 12 seconds. So you might be thinking for a second, this cat is pretty darn slow. It's only 4 feet away. And it takes 12 seconds running? Questionable. So I'm going to start off with here, I'm going to start with 4. Because at 0 seconds it's 4 feet away. But then after 12 seconds, it finally gets to that bowl. It's going to be like a super fat cat. All right, connect your points using a straight edge. And the rate of change. Okay, the rate of change, it is going down again, so it's definitely a negative there. And I think, well, negative 4 feet, so negative 4 feet, 12 seconds. So what the heck is going on? That means it's going down 1 foot for every 3 seconds. So down 1 feet for every 3 seconds. That cat's only moving 1 foot every 3 seconds. Okay, the next one that we did not choose was letter D. So the cat runs away from the milk at a rate of 4 feet per second. Okay, 4 feet per second. So it starts at the milk, and then it starts running away 4 feet per second. So after 1, it's at 4. After 2, it's at 8. After 3, it's at 12. And then I don't have enough there. I run out of room. So I'm going to use my straight edge, connect the points there. Okay, put your arrow on the end to show that it does continue on. And the rate of change, so this was letter D. The rate of change, they basically told us 4 feet per second. So I'm going to just come back across here and say 4 feet per second. Okay, 4 feet per second. Last one, letter E. Okay, letter E, we have the cat was 12 feet away from the milk, and then it runs away from it at a rate of 4 feet per second. So it starts at 12 feet away from that milk, but then it runs away from it at 4 feet per second. So if you look, after 1 second, we're at 12. We should be at like 16, which is already off the graph, so it'll be somewhere up here. Okay, we run out of room. That's fine. We'll just go ahead and plot where we think it might be, and then use our straight edge, connect it, and our graph will look something like that. Okay, the rate of change, again, for this one, is the same as this one, because it's still running away at the same rate of speed, but they started at different starting points. But it's still the same rate of change, 4 feet per second. Okay, going down to number 7 now. So number 7 says, a baby was 9 feet from the edge of the porch. He crawled towards the edge for 6 seconds. Then his mother picked him up a few feet before he reached the edge. Circle the graph that matches the story. Okay, so he's 9 feet away when he starts. All right, if I look at the distance, this one starts at 0. So we know this one is already off. Okay, he's not 9 feet away. I look at this one here. He started 9 feet away. So it could be this one. I look at this one here. This one here says he's starting at 2 feet away. Cannot be that one. Then look at the last one. It starts at 9 feet away. So it looks very similar. Okay, then let's find out what goes on. He crawls towards the edge for 6 seconds. So he crawls at 6 seconds, and then his mom picks him up a few feet before he reaches the edge, which is going to match up with this right here. So he crawls for 6 seconds, and then he's a couple feet away here from the edge, 2 feet away exact, and his mom picks him up. So it's this one. Whereas this one here, we would have like an irresponsible mom there, where it starts 9 feet away, crawls. Mom's not paying attention, reaches the edge, and then tumbles off. So, not that one either. Okay, last page we're going to do for today is page 59, and this one starts off with number 8. So number 8 says, the graph and table below describe a runner's distance from the finish line in the last seconds of the race. Which equation tells the same story as the table in the graph? Use the ordered pairs given in the table to test your chosen equation and explain your choice. Alright, so right now I want you guys to decide, number 8, which equation matches up with this data and that graph. Okay, so when you were deciding this one, you would see here the time at 0. This is important. You got 42, which means the starting point is 42, and I see that on the graph here. Time 0, starting point is 42. So that 42 needs to be represented in my graph there somehow. And I see 42, 42, 42 like this. Here's a 42, but it's 42 times x, which doesn't make sense. So it's automatically not that one. Okay, then I look at the graph here. And the graph from left to right is going down. If it's going from left to right down like this, that's a negative rate of change. Okay, negative rate of change. So here that already excludes letter A, because letter A we got a positive rate of change here, but here we have 2 possible negative rates of change. And basically I need to think, this is negative 6x or negative 7x, which means, is it going down 6 feet per second, or is it going down 7 feet per second? Okay, if we look at the graph here, 42 to 35, minus 7. 35 to 28, minus 7. 28 to 21, minus 7. And again, minus 7, and last, minus 7. So all of those are constant. That's why it's a constant rate of change, which gives you that straight line because it's a constant rate of change. And they're all minus 7, which means it's going to be letter C. Hopefully you chose that one. You start at 42 and you go down 7 feet per second. Okay, number 9. create a table for this graph. All right, so I'm going to start off with here. I see 0 and 5. That's important. So I'm going to put 0 and 5 right there. And then I see where it ends, 3 and 23. So 3 and 23. Now, it's a straight line, which means it's a constant rate of change, which means things have to be changing at a very constant rate, which means it's not going to differ from 1 second or minute, whatever we decide. Right now it's kind of open for time. So I know I can fill 1 and 2 there. And I think 23 to 5. So that right there, is a difference of 18. So I'm trying to think, well, what could be a constant rate of change? What can I add by? I need 18 there to get all the way up to 23. Well, I got 2 spots left. So what could that be? If I take the 2 spots divided by 2, 18 divided by 2, you get 9. So 5, and I'm thinking, well, let's do plus 9. That's 14. No, that's too much there. And then 14 plus 9 is 23, so that's not going to work. Okay, so instead, what else could we use? So 18, 23, and 5. Sorry for a second, I had to reply to a text from my daughter here. Okay, sorry, back again. Okay. So if I'm trying to fill up these two, I need to go by a constant rate. I start at 5 here. If I add by 6, so 5 plus 6 is going to give you 11. And then if I add by 6 again, 11 plus 6 is 17. And then 17 plus 6 gives you 23. So here we have a constant rate of change there. Okay, my story for the graph, it's kind of up to you. You can say time, whether that was minutes or seconds or distance. Okay, so you come up with any kind of story. Let's say this. Use Jose. Jose was running a race. We can say Mr. Knobloch gave him a 5-foot head start because at 0 he's at 5. After 3 seconds he is 23 seconds from the start line. Because here, after 3 seconds, he's 23 feet away. I'm sorry, he's 23 seconds. 23 feet, I used the wrong label there. So Jose was running a race. I gave him a 5-foot head start, so he starts off 5 feet from the finish line. I passed it there, and after 3 seconds, he ends up being 23 seconds from the start line. Which equation would match that story? Okay, if we look at this table here, you got a 0, he's 5 feet away. So I'm looking for this 5, not a 5x. Okay, just a 5, which means that this one is out. And then this one's that. We don't want 5x. I see it's this 5 or this 5. And then I'm thinking, what does he move? Is he moving 6 feet per second, or is he moving 3 feet per second? Okay, if he's moving 3 feet per second, in this case, so 3 times 3 would be 9. 9 plus the 5 that you already had, you started with, would be 14, which doesn't seem to match up. We're here 3 feet per second, so you already had the 5, and you're adding 6 times the 3, which gives you 18, plus that 5, so it's 23. So that's definitely going to be letter A for Jose. All right, and that is it for today.